speaker. This was amazing. You must agree. So prepare to be amazed again. Oren Mילשטיין is the co-founder of StemRad, and he has a PhD in immunology from Weizmann Institute, and he founded StemRad in 2011. So it seems that if you found your company in 2011, you will end up at the Rmon conference in 2018, which is a good sign. So Oren will teach us how to protect space travelers from the dangers of radiation. Please welcome Oren.
Okay, thank you, Ofer, for the kind welcome. I'm very proud to be here in the Rmon conference, and I think what we're doing at StemRad is very special because it's really increasing the safety of astronauts, something that was not fully in existence during the Columbia mission in which he perished. Let's see here. So my colleague David Murrow from Lockheed Martin, he gave an overview about the Orion missions, very successful overview. I won't try to compete with that. But just to say that it's been 40 years since the last time a person entered deep space. We've been doing space shuttles, we've been doing ISS, very important Earth observation science, but only 24 people ever escaped the orbit of Earth. And now NASA is looking to do it again, and they're aiming for the moon in an effort to get to Mars this time. Their chosen spacecraft is a vehicle manufactured by Lockheed Martin. It's called the Orion spacecraft, and they're the prime contractor in manufacturing it. Now, what's one of the major bottlenecks in sending astronauts on Orion into deep space? Well, radiation. It's a big problem in deep space, very different from in low Earth orbit. And as NASA has issued this plea to the public to come up with a solution for radiation, a pretty dramatic plea. I was just wrapping up our first product to protect first responders for the effects of gamma radiation here on Earth. And I thought that we have a solution that can assist Lockheed Martin in preserving the safety of the astronauts they're sending. So what's the problem with radiation? Well, two major elements comprise the problem. One is solar particle events, which are pretty much surprising with very little warning. Talking about a very high dose in a very small amount of time. The good thing about solar particle events is that you can easily shield, or relatively easily shield, the protons that are coming at you. Now, galactic cosmic rays, that's the other part of the problem. It's a constant barrage of low-dose radiation that over a lot of time, months to years, can increase the chances of cancer in the individual. Unfortunately, shielding is not so feasible for this highly penetrating radiation. So the risks are really compounded. When you look at these two elements together, they produce an enhanced likelihood of cancer down the road. And also non-cancerous effects, such as a CNS or cognitive effects. And probably the most troublesome, but the least likely, is an acute solar event, such as in 1972. There was the largest event in the 20th century that happened to occur between Apollo 16 and Apollo 17. And that would have, so to speak, fried the astronauts in Apollo. They would have received acute effects, really jeopardizing the mission itself. So we should really eliminate that risk altogether. Luckily, there are solutions. Unfortunately, whole spacecraft shielding is not possible. It's the most intuitive thing to do. Just surround yourself like in a bunker. Here in Israel, we have many bunkers, but it would be just too heavy. Now, crew repositioning and cabin reconfiguration is a nice word of saying storm shelter. A storm shelter is something that exists on Orion and is very capable in blocking and mitigating the risks of radiation. The only problem with the storm shelter is that it's a very confined space to the point where individuals really won't be able to perform their functions as astronauts, being confined to that space. And a solar storm can last up to 2 weeks, most likely just a few days, but even that would be really tremendous to endure. Medical countermeasures are maybe the promise of the future, but currently do not exist. And magnetic deflection, or so to speak, active radiation shielding, is something that's been in the dreams of many science fiction writers, but has not materialized. So our solution is the StemRad radiation shield. It's a form of personal protective equipment that protects those most sensitive organs in the human body that happen to be rich in stem cells. That's what makes them very sensitive. And we're protecting organs such as the bone marrow and other organs within the human torso to get a disproportional reduction in the likelihood of cancer and in acute effects. Our partner, very proud to say, is Lockheed Martin, who is producing the next-gen spacecraft for NASA. Now, selective shielding is something that we began this art of selective shielding. We began with StemRad 360 gamma, which is a form of shielding that goes around the body's highest concentration of bone marrow in the pelvis, where we have 50% of the body's bone marrow. This product is currently deployed in the most sensitive regions in the world as far as radiation is concerned. It's both for civil applications and for military applications. And the reason we chose to protect the bone marrow is that, as you can see in this CDC chart, it is by far and away the most sensitive organ in the body. And by protecting it, you can really salvage that individual. This is demonstrated in bone marrow transplantation, which is very efficient after exposure. But in the lack of abundant donors of bone marrow, what you want to do is protect it in situ, especially in the space environment where transplantation would be impossible. So the 360 gamma, it has a very unique structure complementing the anatomy of the bone marrow in the pelvis. And we're implementing the same structure only on a broader base in the StemRad. You can see it grew from a belt shape to a vest shape, and this is due to the luxury of working in zero gravity, which affords the ability to carry more weight. And together with the help of Lockheed Martin, we analyzed the efficacy of our product using a simulation based on the travels of EFT-1, the first mission of Orion from December 2014. And we can see really a sharp reduction in the effective dose of radiation. It's true, we're not protecting the head, we're not protecting the legs, but we're protecting those organs that are considered by the world of health physicists as the most sensitive and the most prone to cancer, and therefore reducing the likelihood of cancer by about 50%, which is on par with the onboard storm shelter. Therefore, this is an operational solution allowing the astronauts to leave the safety of the shelter and perform their functions normally. The product has been tested in NASA's Building 9 in Johnson Space Center. You can see the Orion vehicle in the backdrop, and we had human factors testings there, which was really successful. And now the ultimate test will be to test our product in deep space. And we have the perfect opportunity for that. That's Orion EM1. Dave spoke about this exciting mission yesterday, and also General Bolden spoke about this. And it's really the first time in many, many years that a human-rated vehicle is escaping the orbit of Earth and going deep into space where we have this problem of radiation. This is a collaboration between Israel, the USA, and Germany. All three space agencies of all three countries are participating. NASA is providing the vehicle and also dose measurements in the environment of the vehicle. The Germans are providing the Matryoshka Phantom, which has been tested aboard the ISS before, and it's the state-of-the-art in radiation testing. So you're going to have two female Phantom models, one with our vest and one without. The Israeli Space Agency is providing the vest, and we're very proud to be part of this flagship mission of NASA. This is a flyer that's beginning to circulate as we near the signing of this agreement towards this experiment, which is being dubbed MARE, Matryoshka Astrorad Radiation Experiment. This is to be signed most likely in Colorado Springs at the Space Symposium in April. We're very proud to be part of this, and we believe that the results will validate our simulations, and that together we and Lockheed Martin have produced a very needed and successful product. Just to say a few words now in summary, I'd like to quote General Bolden, the past administrator, which I'm a huge fan of. He was here 2 years ago when he signed a framework agreement with the Israeli Space Agency. He said, this is a translation, ישראל ידועה בחדשנות ובטכנולוגיות מתקדמות, וההסכם הזה נותן לנו את ההזדמנות לשלב את ישראל במשימות למאדים. שילוב ישראל יעזור לנו לצבור מומחיות שיסייעו לנו במסע למאדים. וטכנולוגיות מישראל יוכלו לסייע במסע הזה. היינו שותפים בעבר, אבל זה גדול יותר וזה טוב יותר. Just like to recap in saying that this tool, God willing, will be one of the first things worn on the distant planet Mars. Thank you.
תודה רבה, אורן.